Hi. In this video, we are going to continue our discussion of integral calculus for JEE Advanced. We are going to look at a few more problems. So let's try it out. The first question is this one. Integral of 1 minus 7 cos square x by sine power 7x cos square x dx is equal to gx by sine power 7x plus some constant. We have to find out the value of g dash 0 and g double dash pi by 4. So basically, we have to figure out this integral and only then we can find out our g of x, right? Okay, so let's think about how we go about trying to solve this integral. So we have 1 minus 7 cos square x by sine power 7x and cos square x here dx. So one thing you could do is split the integral into two separate fractions and you have 1 by sine power 7x cos square x minus 7 cos square x by sine power 7x cos square x, right? These are two different integrals now for us. And the first integral is integral of sec square x by sine power 7x, right? So we can write it like this: sec square x multiplied by sine power minus 7x dx. This is your I1. And what is I2? I2 is basically integral of 7 cos square x will get cancelled here. So this will become simply 7 sine power minus 7x dx, right? This is my I2. And we have to calculate basically I1 minus I2, right? Okay. So the clear idea here is if you do integration by parts on I1, you might be able to get something similar to I2. So we will try that. We'll try integration by parts on I1. Because clearly there is a function here sec square x whose integral is known to you. The integral of sec square x is tan x. So that is easily integrable. That will be your second function. And sine power minus 7x will be your first function. So what I will do here is work on I1 and try to do it by integration by parts. So we have sine power minus 7x and sec square x dx. This is my first function. This is my second function. So integration by parts will give me first function will be written as it is, and integral of the second function is tan x minus tan x times derivative of the first function, which will be minus 7 sine power minus 8x multiplied by derivative of sine is cos x dx, right? So tan x times cos x will become a sine x, and sine x times this will become a sine power minus 7x. So this will be minus 7 sine power minus 7x. And there is a negative sign outside. So notice that this is becoming sine power minus 7x tan x minus minus 7. So clearly you're getting sine power minus 7x tan x plus integral of 7 sine power minus 7x dx. And what was our I2? If you remember, I2 was the same thing. It was 7 sine power minus 7x dx. And we had to calculate I1 minus I2. So therefore, the second integral gets cancelled out nicely, right? So I1, I2 minus I2 comes out to be sine power minus 7x into tan x plus some constant, right? Now, this was given as equal to gx by sine power 7x. So clearly our gx becomes tan x. And if gx is tan x, then we can find g dash x is equal to sec square x and g double dash x. G double dash x is 2 sec x and derivative of sec x is sec x tan x. So it is 2 sec square x times tan x. And now we can find our values of g dash 0, which is 1, and g double dash pi by 4, which will be equal to 2, and sec of pi by 4 is root 2. So it will be 2 into 2 into 1. So it is 4. So the final answer for us comes out to be 5. The sum of g dash 0 and g double dash pi by 4 comes out to be 5. The question is actually pretty simple. What you had to do was separate the integral into two different integrals. Work on the first one using by parts. If you do by parts on the first one, the second integral automatically gets handled, right? So that was the key idea for this problem. And after that, we are done. It is pretty simple after that. Let's look at the next one. This is question number 2. Integral of 1 plus x power 4 dx by 1 minus x power 4 whole to the power 3 by 2 is equal to f of x plus c1, where f of 0 is 0 and integral of f of x dx is equal to g of x plus c2, with g of 0 is 0. This is the data that is given to us. Now they are asking us if g of 1 by root 2 is equal to pi by k, find the value of k. So they are asking us to find the g function, which is basically integral of f of x, right? Okay, so we can think about it in a step-by-step manner. First, I need to find my f of x, and only then I can try to integrate that, right? So let's focus our attention on the first integral, which is 1 plus x power 4 by 1 minus x power 4 to the power 3 by 2 dx. So whenever you have powers of x like this in the numerator and denominator, one common technique would be to try to like divide both up and down by some powers, right? To try to get it in the form of derivative of the denominator is in the numerator. That's what you want to achieve. So I will try some divisions by some powers of x. Here, if you think about it, I can divide by x square inside, and when it goes outside, it becomes an x cube, right? So if I divide by x square inside, I get 1 by x square minus x square whole to the power 3 by 2. And that x square goes outside the bracket and becomes x square into power 3 by 2, so x cube, right? That is what I have done here. And this is 1 plus x power 4. I have not done anything to this. All I have done is taken out an x cube from here. So obviously I can divide this x cube on top. So I will get basically 1 by x cube plus x on top dx divided by 1 by x square minus x square whole to the power 3 by 2. Now, is that working out for us? Think about it. If you take 1 by x square minus x square as t, you get minus 2 by x cube and minus 2x dx as dt. So you can take minus 2 common and it is 1 by x cube plus x dx is equal to dt, right? So that is great because I have 1 by x cube plus x dx on top. So I can write this top part as dt by minus 2 and this part as t to the power 3 by 2. So my integral is sort of over now, and I can say it is dt by minus 2 and t to the power 3 by 2, where t was equal to 1 by x square minus x square for me, right? So this becomes minus 1 by 2. Integral of t power minus 3 by 2 is t power minus 1 by 2 by minus 1 by 2. So that will clearly get cancelled. You have t power minus 1 by 2 or 1 by root t plus c. Okay? So 1 by root over 1 by x square minus x square plus some c. That is coming as my value here. So I can simplify this a little bit and it becomes x by root over 1 minus x power 4 plus c. That is my function f of x. And now they have given us in the problem that f of 0 is 0. So obviously c is 0, right? So my f of x has come now. F of x is equal to x by root over 1 minus x power 4. And in the problem, they wanted us to find integral of f of x dx because that is your g of x, right? So I have to integrate this now. X by root over 1 minus x power 4 dx. This is a pretty easy integral because I can take x square as t and I can write the top part as dt by 2 and the denominator is 1 minus t square. So that is a sine inverse t integral, right? So you can do it by substitution simply. You will get x by root over 1 minus x power 4 is equal to dt by 2 root over 1 minus t square is equal to 1 by 2 sine inverse t plus c, which is basically half of sine inverse x squared plus c. That is my g of x. And they have given g of 0 is also 0. Therefore, c is 0 again. And you have g of x is coming out to be half sine inverse x squared. And now the question asked us to find the value of g of 1 over root 2. That will be half sine inverse 1 over root 2 is basically 1 by 2. Sine inverse 1 by 2 is pi by 6. So it is becoming pi by 12. A is equal to 12. So we get the answer again. The point here is just try to integrate that initial function, right? We have two integrals in this question. So you have to not get worried by that. Just try to do the integration for that initial function, right? Let's look at the next problem. Question 3. So here we have let f dash of x squared is equal to 1 by x for x is greater than 0. F of 1 is 1 and g dash of sine square x minus 1 is equal to cos square x plus p for all x belongs to real, and we have g of minus 1 is equal to 0. Now they're saying if h of x is equal to f of x for x greater than 0 and is equal to g of x for minus 1 is less than equal to x less than equal to 0, and this h of x is a continuous function, you have to find the value of 2p. 2p is equal to what? P was this value here, which was the term that was coming in the derivative of g, right? They have said that h of x is a continuous function and f dash of x square is 1 by x. Okay, fine. So what can we deduce from the first condition? F dash of x square is 1 by x. Let's think about that. We have d of f of x square by dx is equal to 1 by x. So we can solve an integral here, and d of f of x square is equal to dx by x, and integrate both sides. You should get f of x square is equal to ln x plus some constant, right? And f of 1 is 1. F of 1 is 1. So you put x is equal to 1 here, you get constant is 0. So we get f of x square is equal to ln x from here. Right? Great. So if f of x square is ln x, f dash x square, right? Okay. What we could do, I feel like I made a mistake somewhere. So the point is that d of x square, you have to do d of x square here. It is a derivative with respect to x, d by dx of f of x square will actually not be simply f dash x square. It will always have a 2x term also by chain rule. So I made a mistake here. So let me just rework this part. So we have f dash of x square is 1 by x. So what I can do is I don't want f dash of x square. I want f dash of x. So instead of x, if I replace it with root x, this result is valid for all positive x. So I will replace x with root x. So I'll get 1 by root x. Right? And now I will integrate it because this is f dash x. So I will integrate this. I'll get f of x is equal to integral of 1 by root x dx. This is x power minus half. So minus half plus half. So it is 2 root x plus c. And f of 1 is 1. So 1 is equal to, so you'll get f of 1 is 1, which implies 1 is equal to 2 plus c. So c is equal to minus 1, right? So my f of x function is coming out to be 2 root x minus 1. So the mistake earlier was I was working with f dash of x square, and derivative of f of x square is not simply f dash x square. It also has a 2x term by chain rule. So the best way to work here, before integration, convert it to f dash x, replace x with root x, because the result was valid for all possible x's, right? So we get our f of x function from here now, right? Similarly, now we have to figure out our g of x function from here, because ultimately we have to use the continuity of h of x. So let's work on the g of x function. We have g dash of sine square x minus 1 is equal to cos square x plus p for all x belongs to real. Cos square x plus p for all x belongs to real. And we also have g of minus 1. G of minus 1 is equal to 0. Right. Now think about it. This sine square x minus 1 is what? G dash of minus cos square x, right? Because that is an identity. So g dash of minus cos square x is cos square x plus p. So that just implies that p is a constant. So we can say g dash of x would be minus x plus p, right? Why? Because you have a g. This is your x term, and this is coming as minus of minus cos square x plus p, right? So when you take cos square x as some x, we'll get minus of x plus p here. This should be fairly obvious. Now integrating, we get g of x is equal to minus x square by 2 plus px plus c, and g of minus 1 is 0. So you get put minus 1 here, you get minus 1 by 2 minus p plus c. So what we get is c is equal to p plus half, right? So my g of x is coming out to be minus x square by 2 plus px plus p plus half, right? Correct. And now my h of x function is known. H of x function was equal to f of x for positive x, which was 2 root of x minus 1 for x greater than 0. And it is g of x for x lying between minus 1 and 0, which is minus x square by 2 plus p of x plus p plus half for x lying between minus 1 and 0, right? And the question has said that my h function was continuous. So we can take continuity at 0 by taking left hand and right hand limits at 0, right? So LHL at 0, x is equal to 0, is basically on this function. At x is equal to 0, this function tends to p plus half, and RHL at x is equal to 0 is tending to basically minus 1. So LHL p plus half should be equal to minus 1, should also be equal to f of 0. F of 0 is the value of this part, right? Which is same as p plus half. So that's fine. So p is coming out to be minus 3 by 2. And therefore 2p is coming out to be minus 3. And that becomes the answer to this question, right? So again, we have solved this one. The point here was not getting overawed by the way the question was looking, and keep working in a step-by-step manner. Try to figure out f of x, try to figure out g of x, and then try to work on the continuity of h of x, right? So that was this particular problem. Let's look at another question now. Question number 4. And this question says, if integral of x to the power 2010 plus x to the power 804 plus x to the power 402 multiplied by 2x to the power 1608 plus 5x to the power 402 plus 10 to the power 1 by 402 dx. This is equal to 1 by 10a 2x to the power 2010 plus 5x to the power 804 plus 10x to the power 402 whole to the power whole to the power so actually this is not a, this is alpha whole to the power alpha by 402. We have to find the value of alpha. Find alpha. So the idea is basically, can you integrate this expression? The expression looks weird with a lot of high powers, but the point is that you have to figure out a way to do a proper substitution here, right? Only if you can do a good substitution can you solve it. So think about it. Due to the way the question is structured, this is supposed to be the term in the answer. That gives us an immediate hint that we should think of taking this as our t somehow, right? If you are able to take this as your t, then maybe that's how the answer will come in terms of that t, right? So how can we do that? So think about it. Here you have powers are 2x are 1608 and here the power was 2x power 2010. The gap between this 1608 and 2010 is 402. Similarly, the gap between here and here, the powers are 402 and here are also 402. So it is obvious that I should take somehow a power of x power 402 inside this, right? If I take x power 402 common from here, right, and I bring it, actually you don't have to take x power 402 common from here at all. What you have to take is x common from there, this bracket. This x common will make it x power 2009 plus x power 803 plus x power 401. And here you have got 2x power 1608 plus 5x power 402 plus 10 and whole to the power 1 by 402. And if you try to bring this x inside this now, what will happen? When it goes inside, it will be multiplied by x power 402, right? So x power 402 times 2x power 1608 plus 5x power 402 plus 10 and whole thing will be 1 by 402. And outside what you will be left with is just this one. It is x power 2009 plus x power 803 plus x power 401. That is what is left outside. Now think about this, when you multiply it out, now you start making it look like the term that we need. We get 2x power 2010 plus 5x power 804 plus 10x power 402 whole to the power 1 by 402, right? So now this is very good because you can take this as t, and when you differentiate it, you'll realize that all the coefficients are matching out very well. You're getting 4020 x power 2009, and again 804 times 5 is 4020, and it will become x power 803. And again 10 times 4402 will become 4020 x power 401. So the question is actually done now, and this is becoming basically, we'll write it like this: x power 2009 plus x power 803 plus x power 401, and inside we have 2x power 2010 plus 5x power 804 plus 10x power 402 whole to the power 1 by 402 dx. And we take this as t. And what you get is t power 1 by 402. And when you differentiate this, dt by dx is equal to 4020 x power 2009 plus x power 803 plus x power 401. So dt by 4020 is equal to this multiplied by dx. So this is already there, dx is already there, and what we get is basically t power 1 by 402 into dt by 4020. And so this becomes 1 by 4020, and the integral of t power 1 by 402 will be t power 1 by 402 plus 1. So 403 by 402 divided by 403 by 402. And this 402 gets cancelled here, and we get a 1 by 4030, not 4020, and t power 403 by 402 here, right? And that becomes 403 becomes your alpha, and this is clearly 10 alpha. Right? So the answer for this question is alpha is 403. This is a standard question. It appeared in JEE 2002, and this is a problem that is designed to work in a similar manner. You are taking one thing common from one factor and you are bringing it into the other factor. Once you do that manipulation, the whole integration becomes doable by a simple substitution. Just have to be clever about which one to take as t, right? So a similar problem appeared in JEE 2002, and that's why we are discussing this. It's a pretty standard idea. So that's all for this video. We discussed a few problems. We'll continue with this problem solving series for JEE Advanced. Hopefully you are getting something out of it, and I'll see you in the next video. If you like the content, please subscribe to the channel and share it with your friends. Like the videos, subscribe to the channel. That's what I expect from you guys, your support. I'll see you next time.